हेलो एंड वेलकम बैक। आज के वीडियो में वी आर गोइंग टू सी द मीडिया कॉस्ट प्रिडिक्शन. This is one of the database I find out on Kaggle, and it is very interesting actually. We have around 40 columns, like 40 features, and the shape of the dataset is 60,000. It's not a very big, but it is big as compared to if you are making a POC project, proof of concept project, for your understanding, for your own training, for a demonstration, for learning a new thing. You need a data set, and this is a perfect data set. You can learn from this data set many things. You can do the EDA, then you can do the analysis, you can do the cleaning, you can check all the things, and we are going to perform in this video all the things which are really necessary for this data set. So what we do, this is like a mandatory thing whenever you are creating a one notebook which is related to a data science or analysis. For analysis we just need this. Actually, for analysis we need this library, but for a prediction we need sklearn, tensorflow. For MLA project we need tensorflow, but here we are using the numpy, pandas, matplotlib, seaborn, and warning. We are ignoring the warning thing. So I'll just go and let me check one thing. Can I do? Okay, edit, delete. No, I don't want to delete. Actually, I want to uh, can I restart? Or okay, I'll do one thing. Actually, code is already performed, that's why you can see the below result. So I'll start with this. I'll just install my library. After that I have the pd.csv file that I am going to. Okay, so you can see I use the dot pd dot read csv, and I use a head to read my first five column. If you want to read a specific last column, you use the tail. I want a last five column, so I use the tail. If I want a last 10 column with the tail, I can just write a tail and add the 10, the whatever the count. Now I want my first 10 column, so I'll just write df.head and I'll get my 10 columns. 10 sorry 10 row for 10 first rows with the all columns. So you can see here 10 rows and 40 columns. We have the feature. Whenever you giving a interview, you just may you don't mention the column, you mention the feature. Okay, keep in means keep this thing remember when you giving the interview. Okay. Mm, so we have some categorical data, we have integer data. You can check all the data you have. Like here in sales country we have USA, then we have marital status, married or single person, gender we have male female, all the thing we have, it is categorical or a, uh, a integer value. So you can see here, and we have the parameter called, or a column or a feature called cost. The cost is a column we are going to predict by using this dependent variable. We are going to predict this independent variable. Okay, so uh, so let's go. We have df dot shape, and if you see here, we have 60 more than 60,000 rows and 40 columns. Now if I use df dot info, I'll get my how many entities, means how many rows I have. From it started from 0 and it goes to 60,424 27. Now we have total column of 40. Sorry. And the column name category, food category, this is the object one. So we need this object column into object column converted into a int or float value, so we can perform our algos over there. So I'll go further. The first step in EDA, what we check, the duplicate value. Do we have a duplicate value? So how we check? Df dot duplicated, and we use the parenthesis and then we use the sum. if we have any any duplicate value in a specific column, will get a how many duplicate value we have. So I'll go further. We have zero duplicate value over here. Then we have a second step or a primary step. Df dot is null, and then sum. Do we have any null value in a specific row or a specific column? So I'll go just run this, and if you see here, I don't have any null value or a null value or a zero value in my, not zero but not null value. Okay, so I'll go further and I'll do one more thing. I'll do the describe. So what I get, df dot describe, it give me the column count of the column. So we have the count of every column in the first. Then we have a mean. Then we have a standard deviation. Then we have a minimum value. And then we have a last maximum value. We have 25 percentile value, we have 50 percentile value, we have 75 percentile value. These are the necessary. When we describe, we get this information, and from this information we get many analytical things. So what are those? If we have an outlier in our data, so you can check the minimum value and maximum value. If the maximum value is like, if we have like, uh if you see here, the minimum value and maximum value, if minimum and maximum is in between, but we have a value which is 75 percentile, it is near to the near to the, what I say, near to maximum value, then we can say the data is normally normalized data. Means we don't have an outlier. But if we have a value which is very great or very great than 75 percentile, then we can conclude that we have a outlier in our data. So here we can say the 8 is my value. If you take integer is 75 and maximum value is 22, it's okay. But if I have the maximum value of 8, sorry, 1,000 or 100, then I can say I have the outlier in my data. So this is how you can analyze by just vi- visualizing this data. So we'll go further. Df dot column, how many column we have, and we get the list of the column. After that, I you can see all the column over here, and I saw one column which is repeated over here. If you see average car at home approximately, and the average car home approximately dot one, those two column are exactly same. If you see the values, you can see the values are same, but you cannot check all the value. For that, I have created one simple program. If else condition, if the the column from average car at home approximate is equal to uh, average car at home approximately dot one is all, dot all means we checking the all value. If it is equal means it is same, then it print two column have the same value in the all row. Else it will print two column have the different column in at least one row. Okay, so I'll check all the row and I'll get two column have the same value in all the row. So what we do that time, there is no importance of one of the column. So I'll just go and delete the second column which is come, average car at home. Df dot drop, I write the column name and in place. Okay, after that, doing that, I'll get my column out of the that data set. After that, what I'll do, I'll use the sna dot box plot, and I have the average car at a home approximate, and I use the rotation is equal to 90. And we are using the SNS, from SNS library. We are using the box plot. We get the box plot. This is the, if you see, it is a 90-degree. We are getting the horizontal view. Otherwise, we'll get the vertical view. So this is the 90-degree view. If you see, we have multiple name over here, it will get automatically rotated into 90-degree. But now, right now, we don't have much. But in upcoming session, in coming session, we have some value notation which are many notation in one box plot. So we need this rotation to be 90-degree, and you can see the plot also is in the 90-degree. So I think so this is the maximum value, and this is the minimum value. We have the median in the middle, this is 2. Then we have a 25 percentile, then we have a 75 percentile. uh, so this is it. This is the thing we have over here. Then we have upper tail and lower tail, we can say the maximum and minimum. So this is the upper tail, and this, no, this is the upper tail because this is 4. This is the upper maximum value, this is the lower tail, this is the lower value. Then we have a 25 percentile, this is the 25 percentile, this is the median value, and this is the 75 percentile value, if you see here. So we'll go further, and a df dot now we check all the thing. Now in our EDA, what we check, we have the value which are categorical data. So uh, I'll check one by one. We have the food category, and we'll check all the unique value. After checking the unique value, what we apply unique value count, not unique value. We take that column, then we apply the value count. What we get value count, we get the if I just run this one, I'll just go and make sure. uh I'll just copy this one, I'll delete this one, and if I do this, I'll get the all the value count. If you see, people have vegetable which is value count, then we have a snack food which is value count, dairy, meat, fruit, all the value count we get. But we need what we need, we only need a a 10 specific, first 10. So I'll get the 10 which is started from vegetable and ended with can soup, canned soup, bread, breakfast food, all these things. After that, what I am going to apply, I'm going to apply dot plot. Then I'll put my kind is equal to I need a bar plot. So uh I think I need to give it into, okay. Now I'm getting the bar plot. If you see here, uh, I'm getting the bar plot with vegetable, snack, and all of that. But I don't have a title, so I'll just go and add my title. Top 10 most sold food category. Okay, so these are the top 10 food which is sold. Okay, I'll go again the next column, we have a food department, and I'll go and run this one. After that, we are using the same logic over here. We are taking the value count, first top 10 values of that value of that uh, column, and we are applying the bar plot over there. So I'll just run this one. I'll get the top 10 food department selling most food category. So what we get, produce snack food, produce means processed food, which we get in the packet food. If you go in a supermarket, we get easy to cook, which is like already packed food. When you just you need to, it is instant food, this is the packaged food we can. Then we have snack food which we use snacks food, like then household frozen food, baking goods, canned food, dairy, health and hygienic beverage, and daily delicious or daily food maybe. Then we have a food family, and in food family, what we have, food, non-consumable, and drink. After SNS dot count plot, we are applying count plot because we have a integer value over there. Not integer, but I can say we have a drink. Sorry, I am using the wrong word. If I go, let me go and okay, I'll add one row, one network over here, and I'll check the food slash family. What I get a categorical data. It is a categorical data. But what we have a categorical data which is we can check the count plot. So I am applying the X as a df of food category, and I am getting the who's using the food is like more than 40,000. And then we have a count of non-consumable food, which is non-consumable but it is related to food. Like if someone want not a food, like some uh, a stationery someone want for a home appliances, like that comes under a non-consumable thing. Then we have a drink like Coca-Cola or a soft drink or uh, a water bottle. This come under a drink or a fruit juice. Okay, after that we'll go further. We have sns dot histogram plot. It is from sns library, seaborn library. We have a histogram plot. Then we pass the column name, and we have a beans means we have an interval of a 20. This is depend on a person who is developing the logic. It may be a 20 is okay, it may be depend on data set and the width of a data. So right now we use the bin of interval of 20. If you count this bar, it is a 20 plot, 20 bars. So if I want to increase the bar size or count of a bar, I can just use the bean with the 25 or 30. Then we have a kda, kernel density. I think so I have written somewhere here. Let me check. Kernel density estimate. So what is kernel density estimate? uh, it gives a smooth line over here. You can see the smooth line over here. It is passing from middle of each bar. Okay, and it gives you the smooth line from each bar. This is the KDE is equal to true. So we are getting the histogram plot with line. Okay, we are using the store cost in millions. Now if you see here, I'll get a different value over here. If you see here, I'm getting from 0 to 8,000, and it is started from x-axis 0 to 10. Over here, it is started with 0 to 20. It is depend on data and the value set. Okay, now we have a SNS dot count plot from Seaborn. We are using the count plot. We are passing the our column. So I'm passing my column. So you can see the unit cell in millions. So the count of unit cell, I don't know exactly one for what is meaning by one unit cell. One gives this much count. Then this is the sale, and in millions. If you see the third one, we have uh, a US dollar or something like in millions, 25 millions, 25,000 million dollar. Okay, maybe I don't know exactly, but it is the same as it is. Okay, after that we have a promotion name. We are checking the unique value, and after that we are getting this much value, this much uh, categorical data. After that we have the column which are uh, we cannot go and apply a single column with a count plot or any plot. So we want to check in one image only. So I'm using a simple logic over here. What I have done, I have used the calls is equal to a one variable, and I store all the columns which I needed in one list. And after that, what I use, plt dot figure size equal to 10 by 10. So the size of the this grid is 10 by 10. After that, I have used one for loop, and I'm passing the length of the column. So how many column I have, if I go and pass here, uh, if i if I go and I'll just write the length and I'll pass the calls, I'll get the 5 only. Yeah, but I have more than 5 actually. It is giving the wrong uh, because I'm 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It should give the 11 actually. I don't know why it is giving. So one minute, I'll run this one. Okay, after that running, I'll use that. Now I'm getting the 11 because it is using the previous call in. actually I use the same variable for many time. Usually we don't use same variable in one program, but I have used. That's the mistake you should not use in your project. Okay. We have the length of 11 column length. After that I pass one by one. The iteration will start from 0 and it will run up to 10. So I'm getting the 11 total 11 uh, graph or count plot. After that we have used the p for every iteration we get the plot of 3 by 4, sorry, 3 rows. If you see here, 1, 2, and this is 3 row and 4 column. We are using the 3 row and 4 column, and we are passing our this is the 4 I means column plus 1. So whenever I get the 0, it gives the location of exact first location. This is the first location. This is second location. It is I plus 1 means the first location, second location. It is giving the location for 3 by 4, 3 row and 4 column. After that, SNS dot, we are using this Seaborn count plot. We are passing our uh, x is equal to df dot calls whatever the column we have. So first iteration we get the first column, sale country, you can say sales country. After that I lock, what we need all the rows, and the what we use here a column name. So we get all the rows and the column. This is the column. Okay. So the first all row and the column I get here, I lock. After that I'm using the rotation. You can see the USA is in the 90-degree if you see here. So that's the thing. X ticks means x axis I'll get all the ticks. And we have plt dot tight layout. This is for we use this for not overlapping all the, if a spacing, the line adjusts spacing between subplot, this subplot should be separated by each other, and to prevent the overlapping what we use plt dot tight layout. So it automatically behind the scene वो क्या use करता है, use that, and we get the same spacing between all the subplots, and they are not overlapped, you can see here. Okay. After uh, so I get all the columns like sale country, marital status, then gender, total children, education, member card, occupation, house owner, all this in one logic. After that we have the brand name, df dot brand name, and we use that. If you see here, the brand name uh, column has a really big, this object has very category is divided into a lot of thing, brand name, golden image, and they have like around 50 plus categories over there. After that we do what we use the sns dot histogram over here, and we are passing what histogram, df dot srp, one of the column, and we use that. So you can see here, this is the histogram plot. After that I have the gross weight, and I'm checking so you may have a question why we using the histogram plot. So looking at histogram plot, what we get the distribution of a data, if it is normally distributed or not, or we get any kind of uh, a skew data or anything we get from this uh, histogram. So that's why we use the histogram, and we also get the count of that specific bar or object. Okay. So this is for analysis only. And if you use this analysis, if you have an analytical job or you want to present somewhere, you need to use that, and you need to know what is the this hyperparameter or the parameter we need to pass, because if you know this, you can use it very well. Okay. And you can modify easily as per the requirement. Now what we are going to do, we are using the count plot and we are using the previous logic we have created over there, and we are passing this column from here, and we are using the subplot 3 comma 2 because we are using only we have less number of columns, so we are using 3 by 2, 3 rows and 2 2 columns. Okay, and we are passing I plus 1. It started with first location and end with the last location we have, whatever we have. Okay, after that sns dot count plot, we are passing our uh, x, uh, all the row and the specific column we have. After that we use the x tick, x ticks, and rotate the 90-degree if we have, like here you can see the 90 degrees rotated. And after that we use the plt dot tight layout, which is for spacing and not get overlapped by each other. Okay, and did I, okay, I need to after that we, what we have, so sns dot histogram plot of unit per case. So we are using the histogram plot and you get the histogram plot. Again we are using the count plot over here. I have some, because we have 40, around 40 of 39 features, so we need to check all the rows, all the columns which are necessary to check, and this is the analytical tool we are using. uh, we are using the libraries like for analysis. So what I have done, I use the 15 into 8 grid, like 15 by 8, and I'm passing all the column, and we I'm using the subplot of 2 by 2. So I'm getting 2 rows and 2 columns. If you see here, 2 rows and 2 columns, we have total 4. It is how you can check what digit I have used or what parameter I should pass. My 2 by 2, why I'm passing 2 by 2, because I'm getting 4 columns, so 2 by 2 will be sufficient. If I have 6, then what I have done, I'll use 3 rows and I'll pass the 2 columns, so I'll get the 3 rows. And because it is also necessary, if you pass the irrelevant digit or parameter over there, it will not run your this logic. Okay, and after that I'll pass my first column. After that I use the sns dot count plot. I pass my columns which are mentioned over here in the list, and all the rows and the column name first, and the next tick and the tie layout. So right layout, so I'll get all uh, the count plot over here. Same for here, I'm using the count plot, I'm getting the count plot, but it is uh, if you see here, this is the integer data. You can see here, this is the grocery for square foot, then meat square foot. That's why it is look like many count plot. But if you see here, we have only two categorical data, like coffee bar, we have one is 0 and one is 1. So this is the categorical data which is true or false, yes or no, like data. So the same data I'm getting. We have video store, we have salad bar, we have florist, we have prepared food, yes or no, or whatever the column it is. We are getting two category only over there. That's why it is showing like this. And I'm, so you know the logic very well. Now I'm not going to repeat that logic again and again. I'm just passing all the value. You can see media type, we are getting the all the media type over here. So whenever you have the multiple name in x-axis, you just need to do x6 is equal to rotation of 90, or otherwise this name will overlap. Okay, so after doing that, we have sns dot for a cost. It is our x parameter, we are y parameter we are going to predict in this logic. So this is it. After that we are using the correlation matrix. You can see here the plt dot figure. The figure size is little less, you can make it bigger if you want to. 20 by 20 you can take that. And then sns dot hitmap, and we are passing the in hitmap df dot correlation. This is the after that, a note is equal to true. A note is equal to true means we get the count on each block. You can see here 1, here 0.95. This is the count plot we get when we keep the a note is equal to true. After doing that, we are dropping the cost for our x parameter, and y is the cost we are predicting that. So after doing that, we have completed. Now from sklearn dot model selection, we are importing train state split and x train, y train, x test and y test. We are passing x and y value. We are giving the parameter called test size is equal to 0.20 and random state is equal to 20 42. After that, we have some categorical value. If you see your, if I add one more column, sorry, df dot info, if I pass this one, I'll get, if you see here, I'm still having the object value because we have not pre-process or not process it. We have just analyzed. Now I'm going to process that by using the target encoder. So for that, if you have not installed the categorical encoder, you just need to do one more thing: pip dot install categorical encoder. Otherwise it will show you the error. It will throw error over there. For I have already installed this library in my previous project. That's why it is in Jupyter Notebook only. If you have not that library, just go and install pip install categorical encoder. From categorical encoder, we are using the target encoder. So I'll just run this one. We have the categorical column. Which are the categorical column? How I'm getting the categorical column? So you just need to do one thing. Over here we have the extend, and I'm passing with only working with extend. So we have the extend, and after that select data type. We are using the function called select data type, and I'm excluding which data type, numerical data type, because we want a object type or a categorical type data. So I'm getting the categorical type of excluding means leaving that numerical value, and जो भी दूसरा वैल्यू है वो इसमें ले लेंगे. एंड देन व्हाट आई एम यूजिंग डॉट कॉलम डॉट टू लिस्ट. तो ये लिस्ट हो जाएगा. विल गेट डॉट कॉलम डॉट लिस्ट. सो ऑल द कॉलम we are getting into a list format. Okay. So food dot category, food department, I'm getting all the thing. Okay. So after getting that, what we do, we are store all the data of xtrain and xtest in one of the parameter xtrain dot t and xtest dot t. After that, I'm using the object t is equal to target encoder. I created the object. After that, I pass the categorical column which I have created here. Like this is the column we need to pass over here. I'm using the for loop, and I'm passing all the column which I wanted to pass. So after passing, because I want to fit all of them, I'm using the extend and xtest, and I'm passing my column over here. If you see here, xtrain I'm passing the I, and xtest I'm passing the I. So whatever the column I'm getting, it will fit on all the column which are necessary. So after doing that, I'll get my categorical data, which is all the data. Like if you see here, food categorical data, I'm getting the uh 38 column, and all the data I'm using that. But if you see here, the rows is uh, different, as I mentioned, because we are using the text data, train data, and for testing data we have remaining rows over there. So all the data in the form of numerical only. Now after that, if you see here, we have data in different format. Like I'm getting the 99%, 99 here, 98 here. After that, I have four here. After that, I have two digit value here. I am getting one digit value over here. Over here I'm getting two digit value. So we are getting here, you can see 5 to 10, 5 to 6 digit value. That's the reason I'm using the standard scaler. Whenever you do the standard scaling, it is always before before giving the data algorithm. Before applying the algorithm, you do the step called standard scaling. Whenever you saw the data, it is not normalized or not scale, then you make that data into a scale format. Don't do the standard scaling or scaling in the initial step, because it will affect your prediction. Okay. So I'm using from sklearn pre-processing, importing standard scaler. after importing that, I am creating the object, and I'm passing fit transform on xtrain, and transform on x x test test. Okay, after doing that, I get my uh, X, xtrain cs. If you see here, xtrain.cs, I'm getting the data over here. If you see here, xtrain.cs, but it is in the form of array. So what I have done, i i I need to use one more thing here. Okay, sorry, not here. uh okay, now xtrain, because we cannot give the array data to perform the algos over there. So what I'll use, yes, then what I'll do pd dot data frame. I'll pass the data. We pass actually. Uh, will I pass directly, or let me check? I'll just view this one over here. Then we'll pass the columns is equal to uh, xtrain xtrain dot columns. Okay, after that, I'll add one more thing. I'll just need to check it is in the form of in the right form. Sorry, not CS. We'll use CS. Oh, it's not CSSC. Sorry. Now I'll get my. If you see the type here, if you see the type here, sorry, I need to complete this parenthesis. If you see, it is a data frame, and if you see the type of this, will get what I'll get. If you see here also data frame, here also data frame, because we have if you, because we run this one, and that's why I'm getting here also. Okay, did you understand what I'm trying to say? Because I have performed this one, means I have okay, I'll do one more thing. I have not performed on xtest. I'll do on xtest. You will get it, xtest dot c, and I'll go and make this one column. And if you see nd array, because this is a numpy array. Okay, so now I'll do this for same for X test also. Okay, I'll just do the test over here. I'll pass my test over here, and also column name. You see, I'll complete it. Now if I see the type of X test dot sc, and I'll just make this one. Uh-huh. Yeah, I'll delete it. Now you can see there. Here is the ND array, and it is a data frame. So we have, what I've done. We have converted into a data frame. Now what we do, we apply the algo. For that we need algorithm sklearn dot linear, because this is the linear model, because we have the uh, continuous data. So what we apply, the simple algorithm called linear regression, and we are using this matrix to evaluate our model. So for that, what we have, r2 dot score mean square error. So I'm using that. R2 score is for accuracy, and mean square for how much error we have. Okay, I have performed that. And if you see here, I have created lr dot object. I have created the object of linear regression. Then after that, lr dot fit extend, and what extend we have passed, this one. Okay, and by train over there. After that, we lr dot predict, we pass the x test over there. And for To score what we need y test and y pred, which is this is why we have calculated. So r if I run this one, I'll get my R2 is point 0.3, which is very less. Accuracy is like 30% only, and RMSE is less, not less, but it is. Oh, sorry, it is 24. Means it is very big. Means error is very high. That's why it is not appropriate to use the linear regression over here. And if you see mean square, if you want to calculate the root mean square, what you do, mean square error, and you pass the y test and y pred, and you just do one thing, square is equal to false, squared is equal to false, to get the root mean square value. Okay, after that what I have done, I have applied one more algorithm called decision tree regressor, because we have a regressor problem. I have created the object. After that I fit that, and after fitting that, but what, can you can you see I have used the not this one, I need to use this one. Okay, now, and over here also the CS one. If I go here, I need to use the, this one is okay. Okay, let's see what we get. Is not defined. Oh, I'm using one. So we are getting the 99.8, means 99% of accuracy, and the error is 1. It is negligible. So you can see this is the perfect algorithm we can apply. Decision tree will get a perfect means we are getting, like, it is surprising actually for me to get this much of accuracy, because I have applied before that, I know that, but it is surprising for to you also. So thank you for watching this video and perform this uh, a Jupyter notebook. I am sharing the link also, and I am sharing the link of dataset below the video also. So go download that dataset from Kaggle and perform this task. You will be very clear. You get all the doubts clear very soon. And if you have any doubt, just comment down below. I'll make sure ki I'll I'll solve your doubts. And if you really like this video, means if you like this, it will appreciate it. And please subscribe to the channel, because I'm getting very less subscription. So thank you, it is motivating for me also to get a subscribe from your side. Thank you.